Swayam Prabha. Digital India. Educated India.
Hello everyone. We learned about some basic hello everyone. In the last lecture we learned about some basic assembly methods that were some standard mates available in SolidWorks. Now in this lecture we will go on to learn some advanced methods of the methods featured in SolidWorks. So now let's see the mates. We learned about these standard mates over here. Now the next things here is advanced mates. So now in this lecture we'll go about these advanced mates one by one. Let's see some of the parts that I have loaded here. The first mate here is profile mate. In this profile mate allows us to align the center, geometric center for two profiles or two surfaces to align over each other. For instance, let's just check this particular profile, this rectangular profile, and say this circle of this rod in the profile center. Now it automatically aligns the two of them to each other. You can see these two getting aligned to each other. Once again we can see, say I want to align this particular face over this larger rectangle. So we will go to mate, we will go to advanced mates, then this is profile center over here. So we can see this plate is getting aligned, the plate center of this face is getting aligned to this larger one. So however, we can see this inverted. To flip this, we have this here option alignment. To invert the alignment, this is anti-aligned. So we can see over here aligned in the correct way. So this here is profile center. So for the next one that we have here is symmetric mate. Symmetric mate allows us to move two items, two elements as a symmetry. We can couple them as if they were mirrored along a plane. Sorry. So the next mate we'll talk about is in advanced mate is symmetric mate. Symmetric mate allows two elements to behave symmetrically to each other along a reference. So we will see here, let me just set up the geometry for this. We will remove this profile center. I will set up. So here we have some random fixture assembly. So you can see here this plate is rotating about this shaft, this is rotating about this shaft. So let's just check the symmetric mate over here. So we'll go to advanced, then this symmetric. So this symmetric mate allows us to select two things. So, one we need the symmetry plane about which the elements have to be symmetric about. So, let us select this plane, or maybe we can select from this hidden planes. Let us select this front plane from the middle, and we will select the symmetric plane allows us to select two items over here. First one is we have to set a reference about the plane. So, we will see plane. So, we will go to mate, to advanced mate, then the symmetric one. Symmetric plane allows symmetric mate allows us to select two things over here. You can see this is symmetry plane. This is the plane of reference that is between the two elements that we will be selecting. Let us just select one plane. This will just enable to see the plane. Let us select this plane, and for two elements we will be selecting this face and say this face. Just click it OK. Again. So, the next mate available is here is symmetric mate. We will go to mate, and we will go to advanced mate, then symmetric. So, in the symmetric mate we can see here two little windows. So, first one of them is to select the symmetry plane of reference that would be the reference for the two items that we will be selecting. So, for this plane of reference, let us just select say this plane, and the two items that we want to be symmetric about is say this one and this. So, we will click OK. So, now we can see this particular face and this face is symmetric about this plane of reference. So, as we rotate one of them, the other one behave symmetrically about each other. We can see the details again. Click right click over here and to edit. If we want to anti-align them, we will click here and OK. So, the next mate available over here is width mate. So, let us just delete the earlier ones. Symmetric mate. We will see here you can see this particular latch kind of thing is movable to anywhere there, and it is not fixed as of now. So, suppose we wish to have this latch in the center of this shaft. To have this, we have the mate advanced mate called width. We will go to advanced mate width. Here again we have two little windows. This is the reference for the width selections. We will select reference 1, reference 2, and the item that has to be in the center, say this one and this. So, once we fix it up, so we can see this is fixed in the center, and it is in the middle of this plane and this particular plane. So, this is width mate. In line with that, we will talk about rest of the advanced mate. We will check with this distance mate. this is called distance limit and this is called angle limit. We will check with this. First of all, let us just delete this width mate that we have just in. We will go to mate and this distance limit. So, for now as I have shown you that this is movable to along this shaft and it does not have any limit. So, to set limit in onto this latch, we will just click over this and it gives us a maximum limit and its another, this is minimum value. So, for we will have to select the face, say this face and this face. So, we will select a maximum distance between these two and a minimum distance between these two. So, I am selecting 0.49 and say here it is 0, click OK. So, I have set the limit between this face and this face. So, we can see the minimum limit was 0. So, it cannot move beyond this 0 value and the maximum limit was 0.49. So, it has set up to a maximum distance up to 0.49. So, this is distance limit. Similarly, we have angle limit as well. To set angle limits, we have to again select two reference planes. This is angle. We will select say this plane and this plane. I am setting a value Similarly, we have similar to the distance limit, we have here is angular limit. So, we will go to advanced mate, we can see here angle limits. So, same as in distance limit, we have again the two selections to be made. Let us just select this plane and this plane and we will select a maximum value and a minimum value. Let us make it, let be 30 and we will make this as, let us make it 180, we will keep it 30, click OK. You can see it has a, it cannot rotate fully. Let us just fix this item. Okay, click on fix. Similar to the distance limit, here we have is angular limit also in the advanced mates. This is for angular limits. This again asks us to set the two reference plane between which the angles has to be set. Let us just select this plane and say the top plane. We will set a value that is maximum and one is minimum. Let us just select 30 to be minimum and say 180 as maximum value. Now, we can see this shows a constrained motion in axial in this angular direction. So, this limits is set up by this angular limit in the advanced mates. So, this was angular limits. The other mates available here is in advanced mate is path mate and linear couple. We will see that in some other geometry. Just kill it. The other mate available in the advanced mate is path mate. For path mate, we will see in this geometry that this ball is supposed to move into this curved slide. To make this possible, we will have to select the path mate. So, for that we need the center of this ball to slide along the center axis of this slide. So, for now we cannot see the center of this. So, and the center line of this particular curve. To enable that, we will go to this ball and we will select the sketch part and we will make it show, and similarly on this particular slide, on this swipe, we will go to the sketch. So, now we can see the curve and the center of this. So, now in path mate, the path mate asks us for the vertex, that is center of this ball, and the path that it has to travel along. So, this let us just select the component vertex to the center of this ball and the path as it is not visible as of now. We will just activate here, sketch, make it show. So, now again this path, we will click OK. Now, we can see that the center of this ball is aligned to this spline of the slide, curved slide. We can hide that sketches. You can see the ball is fit into this curved slide. To see that, let us just make this transparent. We will right click over here, this change transparency. You can see here this ball can move into this. However, as we know that I have imported this ball for the first and then this plane. So, this is already fixed. So, let us just make it floating and make this fixed. So, now you can see this ball can move into this slide. So, this was possible by using path mate. Let us just see the next advanced mate available, that is linear coupler. We will check that on some other geometry. Let us just load it. I will delete this one. We will go to insert components for linear coupler. I am loading. Here we have some wheels and some rail tracks over here. So, linear coupler allows a coupling between two items in a linear fashion. We will check that. Let us just make these as tangent over each other. We will go to insert component, select some of the parts. I here have some parts, that is wheel, a track and a wheel top. We'll just fix this top to this wheel. Just made it. I'll make it tangent. Here we have this track and this wheel. So, I need another wheel to demonstrate this linear coupler. I will do the same thing with this other wheel. Now, here we have two wheels available. Let's just align these wheels to this rail track. I'll make it mate. So, now we go to insert components. We will load some of the parts over here. Here we have a rail track, a wheel and a wheel holder. So, we need two wheels to demonstrate this linear coupler. We will make a copy. Let's just set up these wheels. I will align this wheel to this rail track. Once again, to have this wheels in the middle of this track, you can use width mate, that is reference 1, then reference 2 and the item to be centered. We here have similarly here. I will just put the heads over the wheels. So, we will go to now we will go to this insert component. We will just insert some parts. Take a, we will here have a wheel connector, and let us just insert some components. We will take a train track and wheel connector. We here have two items. Let's just we need two different items to demonstrate this linear coupler. I'll align these two in the rail track. So, here we have this slider kind of thing. So, both of these are independent of each other. So, now we will check this linear coupler. We will go to mate, to advanced mate, and here we have linear coupler. This asks us to select two particular elements. Let us just select this face and this face, and we will set one ratio between these two. Let us just select 1 and 1 to each other. We will click OK, and as we move this item to in one direction, the other one automatically couples to that and move in the prescribed ratio. Let us just change the ratio and check that. We will edit the feature. I will make it say 1.5. Now you can see it the next one accelerates, and as in the ratio 1:1.5. So, this is linear coupler. So, here we have finished this advanced mates. In the next lecture, we will go about the rest of the mechanical mates that we have left over. We already have covered this screw mate and this hinge mate from mechanical. So, now we have completed this advanced mates, and in the next lecture we will go about learning this mechanical mates, that are cam, slot, hinge, gear, rack, pinion, screw, and we already have So, now we have finished this advanced mates available in this SolidWorks. We have covered all of these one by one: the profile center, the symmetric, width, path mate, linear coupler, distance limit, and angle limits. In the next lecture, we will learn about the mechanical mates. Thank you.